And now, ladies and gentlemen, let me share a few lines about our next DevOps speaker. He is the Chief Z DevOps Advocate for Broadcom's Mainframe division. He is a recognized industry evangelist of open source and DevOps on the mainframe and an award-winning speaker at popular IT conferences such as Share, IDUC, DevOps Enterprise Summit, and IBM Think. He has been a creator of the mainframe DevOps tool CA Brightside, which won the Most Innovative DevOps Solution of the Year award in 2018. And this year at the DOIS 20, he's joining us now to shed some light on DevSecOps policy as code for mainframe. Coming to your screens right away is none other than Mr. Sujay Solomon. Sujay, a very warm welcome. Over to you.
Welcome to the session on policy as code for mainframe. My name is Sujay Solomon. I am the DevOps product management lead for the mainframe division at Broadcom. So today we're going to be talking about a few topics here. So we'll start by kind of just introducing you guys to software engineering governance and why it's important in today's climate, and then relate it to how it applies to mainframe and how policy as code is actually helping with automating more of this, and some of the patterns that we've seen with respect to control points that people have come up with in PAC platforms. So you'll see me referring to policy as code as PAC quite often during this session. I'll also share a little bit of a reference architecture or conventional implementation that we've seen, and then kind of taking that architecture and then adapting that to mainframe, and we'll conclude there. After that, we'll go into any questions that you might have in the session. So, applications have to meet SLA. There's expected response times. There's infrastructure costs that need to be met. They have to be within your budget. There needs to be security applied at various levels. You have to be dynamic. The application has to be dynamic with respect to reacting to faults that might happen. And all of this doesn't just happen on its own, right? Over decades of software engineering, the industry has continued to build more and more governance around these software engineering structures, processes, policies, with the aim being that we want to maximize the amount of business value that we get out of the software change that's happening. But at the same time, we have to be able to mitigate risk to the greatest extent as well. So that's why there's been a lot of evolving levels of governance around software engineering. Now, why is this important today? So a few factors that are really driving this and bringing this to the forefront today is, first one is really maturity of DevOps. So, about 10, 12 years ago, DevOps was still in its infancy, and there was a lot of evangelization going on around why it's important to automate your build and automate your deployments and, standardize around that. Now, that has become reality, and DevOps is pretty much assumed as the process that most software teams follow today. But with that comes a lot of automation, and that automation must be governed for it to perform properly and can be trusted. The second factor is the emergence of microservices architecture, where rather than monoliths, we've really moved towards having many different services. And that means there's just more and more services that need to be looked after and governed. And of course, federated data management is another reason. And the last one here is the outsourcing of infrastructure management, and in some cases, even application maintenance and so on. So there's multiple parties at play. You might have third-party vendors. You might have service providers who are also in the mix. Or even if everything is in-house for you, a lot of times you're probably using infrastructure platforms that are possibly public or a cloud, and therefore not everything is under your control. So because of these factors, software governance has kind of gotten a renewed interest to see where we can move it along and modernize it. Now, Plenty of applications still run on the mainframe. In fact, most of the critical application on the financial sector and retail and so on, it's an absolutely critical platform for them. The platform is extremely good at transaction processing, batch processing, but there's modernization occurring with the applications there as well. For example, people are laying in APIs on top of traditional transactions and so on. But as part of putting APIs on top of these layers, some refactoring needs to be done to get there. So that's happening. And that's causing business logic changes to happen. And of course, as part of doing those things, you still have to ensure that your response times and your performance in terms of resource consumption and so on still is optimized. So these are factors that are driving changes, which are really bringing governance to the forefront on application development, software engineering on the mainframe side as well. Now, here's where policy as code comes in. So you've got this growing set of governance and policies that you've got in place. And policy as code is really the idea of taking all of your governance, all of your policies, and turning it into code that's written in a high-level language, which allows you to manage these policies, and also the possibility of automation opens up now. When you start actually converting your policies into code, you're then able to apply the standard software development practices such as version control. So you can take your code and throw it into Git. Or if you want to actually test your policy as code itself, you can write automated testing around it. And of course, you can automate your deployments of it as well. So that actually came directly from HashiCorp. I have no affiliation with them, but they actually are in the industry where they provide a platform called Sentinel, which allows you to implement policy as code. So, but why are folks actually pushing towards policy as code and converting their policies into code today? So 4 major reasons here. So one is to put some guardrails around the enormous amount of automation that's in place today around your build, around your deployments. And policies really provide certain guardrails for other established automated systems. So as the number of automated systems grow, there's a growing need to protect those automated systems from doing things that are dangerous. And PAC really allows you to govern this automation and prevent some of these hazardous situations from happening. The second reason, which I kind of highlighted before, is once you start codifying your automation, just like your build automation, your deployment automation, or infrastructure as code that you might have, when you start turning your policies into code, it comes with the usual benefits and standards that you can apply to code versus, say, having to do some verbal communication in terms of, hey, you need to make sure that the security scans are done, or you have to make sure that dependencies are coming from a trusted source that's internal, not from the internet and so on. Those kinds of things, if you turn it into code, it can be more easily governed and you're not just relying on verbal communication between people. Another reason is, of course, quality of your policies themselves and the way you're enforcing them. PAC, or policy as code, can be put through the rigors of automated testing, just like any other code, to make sure that it's reaching the right level of quality. And perhaps one of the biggest reasons that people are implementing policy as code is audit readiness. So when you've got automation for your policy enforcements, you can easily generate reports for them with just loads and loads of history. You can go back as long as you want, and the control points really allow you to make your audit process just extremely straightforward. Perhaps the biggest reason of them all that folks are moving towards PAC is in order to automate and reduce red tape. Now, what do I mean by that? So I'll share an example here. So, I've worked with a lot of large enterprises on the financial sector, and one of them in particular shared a situation with me where a single application team had sort of gotten into a bad habit where it was a team that was doing application development on the mainframe side, and mainframe applications have been around for decades, right? 30, 35, 40 years. And over the course of that time, they had established lots and lots of approvals and process and reviews and governance boards and so on. Just, extremely lengthy process that it takes for them to get from coding into production eventually. Now, this application team, over the time kind of grew tired of this process, and believe it or not, they had kind of an emergency deployment path, which was only supposed to be used for, say, hot fixes or absolutely business critical things that have to make it into production right away. But this kind of became their normal path, where they were just bypassing all the governance and the process that was put into place because they didn't want to put up with it. Now, how they flew under the radar while they were doing that, I don't know. But they've grown into this bad habit of bypassing all of the governance because they just did not want to wait around and go through all of that rigor slowly. So in order to prevent that, implementing a lot of your policies as code and automating it is going to just absolutely speed up that process. And it's also something that becomes trusted, and it's something that's expected. So, you know exactly what that process is. There's transparency around it. Even a developer can go in and look at what that process is, and there's not a whole lot of unknowns for them. Now, going around talking to a lot of these customers who are actually implementing this, there's been quite a few control points that have been established in the industry around this. I'm going to walk you folks through some of it here, and by no means is this an exhaustive list. In fact, for every organization, the control points are going to vary. You really have to look at your process, your governance, and adapt it to what control points you would like in your policy as code platform. But just sharing some of the ones that I've seen. So build versioning. So when it comes to build versioning, each individual build really should have a unique identifier which can be used to then trace back to the execution of a pipeline that actually deploys it. So pretty common item that I've seen. Code reviews, right? This is quite obvious. I mean, a lot of times people want to enforce that a certain number of reviewers, maybe 3 or 4 minimally, are part of the code review process, and that has happened for a code change that's coming through. Next, test execution. Now, this is not code coverage or anything. This is just the fact that there's tests that are present, so unit or integration tests are present and have been executed. It does not try to actually take into account percentage and so on. Static code analysis, of course, code quality checks, things like SonarQube and so on, just best practices being observed to confirm that those checks were done and that certain levels were achieved there. Now there's test coverage. So, for something like unit tests, you might enforce that a certain percentage of code coverage is achieved for any code change that's coming through. For integration tests, it might be something like you classify your integration tests into different categories as extremely critical, recommended, or nice to have. And you may enforce a percentage of each of those levels of criticality of tests to have to be run and must pass. So obviously for the top level, the extremely critical level, it's likely going to be 100%, and maybe for the lower levels, it's going to be a little bit lesser than that. That's up to your policy. Package security analysis. So scanning after your build is done for undetected vulnerabilities and so on. So you might have done static analysis before you did your build, but you would also want to scan things after your build artifact is present. Build configuration review. So this involves making sure that your configuration of build is also peer reviewed. So it's not just code and application changes that should be peer reviewed. It's also the build configuration that changes that should also be peer reviewed. Now, package trusted sources. So this is one where the packaging system is really restricted to only use approved dependencies, meaning you might not be allowed to go out and get dependencies just from the open internet and so on. You must get it from sources that are reliable. Next one is to actually safe list your staging environment network connectivity. This is to protect yourself around non-production deployments having access to mission critical production environments. You really don't want that. So assuring that that's not happening is a policy I've seen. Upstream approved dependency management. So this is where your open source packages, your third party packages also need to have gone through vulnerability scanning. It's not just what you've built, but your dependencies that you're getting from other sources also must be scanned. Metadata for packages. This is very custom per site. Whenever you're delivering packages and you're deploying them, you might require them, your application teams to actually embed some metadata as part of those deployments. This is to ensure that the metadata has been generated and included as part of the package that's being delivered. Next, you've got artifact retention. So, here's where you've got artifacts that you're deploying, and you might have a policy that indicates that any artifact that actually goes into production must be retained for all your releases for a certain amount of time, or possibly even indefinitely. So anything that gets into production, the binary artifacts must be retained for a length of time. Security analysis, of course, scanning for security issues and vulnerabilities and making sure those pass. Your artifact itself must be immutable and cannot be altered, and that you want confirmation of that. You might have a digital signature of the artifact where the policy as code platform will actually sign the artifact to make sure that it's authentic. You might have something like, binary trusted packaging, where packaging systems should only be downloaded from dependencies which are trusted sources. Information leakage, where you might have your automation that's in your CI/CD typically has to authenticate itself to a variety of services. It's pretty easy for folks to kind of embed things like passwords and IPs and ports and so on into that. That's frowned upon. So by policy, you want to confirm that secrets such as user IDs, passwords, and so on do not exist in your source code, whether that's application source code or if it's infrastructure as code and so on. Finally, another one I've seen is test data destruction. So this is making sure that the test data that you might create, copy from someplace and into your test environments and so on. After your testing is done, you want to confirm that this data is actually destroyed and there's no leftover pieces there. So not exhaustive, but a list of control points that I've seen folks implement as part of their pack adoption. All right, so those are concepts and standard control points that we've talked about. But what about the technology that allows you to actually implement something like this? So here's an example. So this is Grapheus, and this image is actually from Google Cloud Platform's introduction to Grapheus, and I'll do a quick walkthrough of this here. You're able to use Grapheus and other tools to really audit and govern your software supply chain. And here's an example that they share. So you've got somebody checking in code for a component that they're working on. And that activity of checking in the code is actually going to possibly throw a webhook that's going to push the authorship information to Grapheus, which is collecting and consolidating all this metadata. Next step in your pipeline is it safe to actually perform a build of this component? So we made the source code changes. That was pushed to probably your SCM. Then you're now performing a build. Now, before you perform a build, though, Grapheus is going to actually tell you if, yes, the components have been confirmed to have an author who can be trusted. So go ahead, you can do the build. So the build will be done. Then the pipeline is going to invoke something like a third-party component scan. That scanner is going to do its job. And the results are actually going to go straight to Grapheus. And it's going to be added as part of the metadata that Grapheus actually maintains here. Next, after the scan, you're likely going to run through some tests. So the tests are run, and the test results, of course, are also shared with Grapheus. And if there's sign-offs and approvals involved, that's also recorded in Grapheus. Finally, you're kind of ready to do a deployment here. You might ask the question of, does my component meet security policy? And you're going to get that information as a pipeline directly from Grapheus. Yes, this component has actually been certified and is free of vulnerabilities. Go through your deployment to wherever you're deploying. There's the confirmation that the deployment has been done for that component. That also goes back to Grapheus. And now you've got folks like CIOs and so on who are able to actually go into this platform and look at a summary of everything that was deployed and whether their governance and their policies were followed as part of that deployment. So simplifies a lot of these things. And at this point, you really don't have to believe people that they've followed the process. You've got a platform that's telling you exactly what was done and can be trusted. So that's kind of the advantage of this concept of policy as code here. A common configuration that I have seen around this is, you typically have a CI/CD orchestrator. Could be Jenkins, TeamCity, whatever it is your preference is, and through some sort of an API, it's going to call your system of record and perform things like builds and quality analysis and security analysis and so on. And from those systems of records, there's typically a webhook or an API that calls into the PAC platform, which then stores the metadata that's produced by this system of record. Now, notice, it's important to notice here that the CI/CD orchestrator is not passing the information on to the PAC platform. So it's not playing middleman from the system of record. The information is coming directly from the system of record into the PAC platform, because the PAC platform will only trust its source being the system of record. Now, the PAC platform might not get everything that it wants in the initial payload from the system of record. So it might do further API calls to get more metadata from here and store it in the platform itself. But once it's gotten all the information from its system of record and it has determined that a certain policy has passed, then it will let the CI/CD orchestrator know that, yes, this policy has passed, and you are free to move beyond this step and go into the execution of your next step in your pipeline. So that's a very common configuration that I have seen. We're talking about mainframe here, right? And this type of policies, and as I mentioned before, there's just so much governance that's been built into the mainframe side over so many decades that this is really ripe for automation and modernization here. So some steps that you might want to take in building this out for the mainframe side is, you need to identify your control points first for mainframe. They may almost all be the same as what I mentioned, but like I said, depending on the application, on the platform, and on the specific customer site, there might be a few differences, some customized control points, and so on. But once you've determined your control points, you can then actually start developing policy as code by using open APIs, CLI interfaces, which are provided through interfaces like Zoe. And you can retrieve trusted information from the ZOS platform and check to see if your policies are really being satisfied. And of course, trust built into that because you're getting it from the system of record rather than from some middleman. Just to highlight again, policy attestation is only achieved if the information that you're getting is verifiable, signed and so on. And the preference always is to get it from your system of record rather than something in the middle. Without that, you are open to any kind of manipulation, right? And I guess to give it a little bit of a depth there, let's say, for example, that you're perhaps getting the attestation information for a policy from application code or from your CI/CD pipeline. It could easily be manipulated with a script that says, hey, just force feed this information into the pack platform to make the policy pass. And if that's allowed, then your policies as code platform really can't be trusted because it's not getting its information from trusted sources. So that's a key aspect of implementing pack, is that you really need to make sure that your source of metadata for satisfying your policies is coming from sources that you absolutely trust and can verify that they're trusted sources. Now, on the mainframe side, though, I mentioned that Zoe provides a lot of APIs and CLI interfaces that allow you to actually script up this type of automation. But your mileage may vary there. We're kind of we're at a maturity level there, but it depends on what vendors you're working with, what type of software is on your ZOS machines, and you might need to kind of contact some of them and let them know about the need for these APIs and CLIs if you want to query them for pack purposes. So there's an open question there. I want to take a moment here to relate some of those pack control points to mainframe specifically. So take build versioning, for example. On the mainframe, large majority of code is stored on a platform called Endeavor. And Endeavor typically acts as the source control, the build machine, as well as the binary artifact manager. And it really is the system of record for code changes and builds on the mainframe. So it should be able to provide you an identifier that allows you to actually trace the build back to the execution of a pipeline. Now, code reviews. So you've got some options here. Code reviews, if you're doing it in the traditional way where folks have packages that are created in Endeavor that allow you to actually see which elements are being changed on the mainframe side, and they let that drive their code review process. And you can take information like this person A, person B, person C was part of the code review. That can be documented and embedded into the Endeavor package element. And you can, of course, through APIs, through Zoe, you're able to query that information and confirm it in your policy. Alternatively, Endeavor actually also has the ability to connect with Git servers such as, GitHub, GitLab, Bitbucket, and so on. And in those cases, you might be performing your code reviews aligned with your PRs, your pull requests, and you can get your number of reviewers directly from the pull requests from any of those Git servers as well. So a couple of options there for the mainframe side. Now, when it comes to test execution, mainframe testing can now be automated, developed using modern test frameworks like Jest or Mocha or Karate and so on. So a variety of test frameworks that are popular on the distributed side can also be used for functional testing, for load testing. Interfaces like BlazeMeter and so on are out there. Typically, the results and the execution of these tests are fed into a quality gate such as SonarQube. So we typically see SonarQube quality gates as being the source of trusted information for this particular control point. Likewise, with static code analysis, where the quality gates within SonarQube become the source for this as well. So, SonarQube supports COBOL scans, and it's quite popular these days to pump any code changes that are happening into SonarQube for your COBOL scan, and then get the results from there into your pack platform to pass your policy. Now, you might also get your test code coverage results pumped into SonarQube, Sonar quality gates, and you'll get confirmation from there as well. Or also percentage of tests, right? So if you're running integration tests and you're covering them for by level of criticality, those might also go in and come out of SonarQube quality gates. Of course, staging environment, network connectivity, safe listing, that is, you might not want connectivity to certain LPARs from your deployment platforms, and that can be enforced pretty easily just through IP and so on. Metadata for packages. Endeavor can actually attest to this metadata being stored as a part of the package element. Again, so if you have custom metadata that you need delivered as part of your packages, you can enforce that through Endeavor. Binary trusted packaging, again, Endeavor is the source of package level dependency resolution and can absolutely provide data about the source of dependencies, whether it's coming from a sys1 data set or something of that sort. Endeavor has all of that information, is able to share that with you so that you can attest to your policy passing there around trusted packaging as well. And finally, test data destruction. You should be able to query things like ZOS datasets, DB2, IDMS. All of these things have APIs and so on through Zoe, and you should be able to query them and confirm that your data has been destroyed as well. Now, taking the configuration I shared before and adapting it to Mainframe, it's really no different, right? It's similar pattern. You've got your orchestrator. It's performing things like building, packaging, deployments, tests, and a lot of this is happening on the ZOS platform. And from there, you're able to drive through either webhooks or through APIs into your pack platform. I mean, obviously, this requires some customization and scripting from here. And the pack platform can use Zoe to query back into these mainframe services to get additional metadata. And once it satisfies your policies, no different. It'll let the CI/CD orchestrator know, and it'll move on to the next step. So this is really part of Zoe's goal, is to ensure that the same patterns that are applied on the distributed side when it comes to CI/CD automation, modernization around DevOps, the same patterns can be applied for mainframe as well. Now, I don't have time in the sessions to go into great levels of detail with Zoe, but Zoe is an open source project that was launched by Broadcom's IBM and Rocket Software a few years ago. It's under Open Mainframe Project, which is part of the Linux Foundation, and it really aims to open up the mainframe platform through APIs at the bottom here, govern them through an API mediation layer with respect to network, security, connectivity, and so on. And one consumer of these APIs is the command line interface, Zoe CLI, which allows you to script up automation such as policy as code, build automation, infrastructure as code, and so on. So anything that you want to automate, typically that you would use, maybe with a cloud platform like AWS or Google Cloud, you might use their command line. The same way you're now able to use Zoe CLI to perform scripting and automation of similar practice. There's other components in Zoe that really isn't relevant for our discussion here today, so I'm going to skip over some of them. Now, I mentioned that your mileage may vary depending on which software is running on your mainframe. From a Broadcom perspective, we are completely dedicated and invested into building these open APIs and CLI interfaces for a lot of our products. So you can see this list is just continuously growing. We've got things like Endeavor, Mainframe Application Tuner, JCL Check, SysView, OpsMVS. So it's not just with our development tools, it's absolutely also with our IT and operations tooling as well. And you can also see a lot of these APIs and command line interfaces actually have something called Zoe conformance, which really, it gives you the trust in an open source platform like OMP and Linux Foundation that we've built these APIs and CLIs to a standard level of conformance, which you're able to trust and use in your mission critical automation and so on. So, list here, and if you've got other products that you would like to query as part of your policy as code implementation, just let us know, and we'll be sure to prioritize building API CLI for those as well. So in summary, just a few takeaways that I'd like to highlight here are, policy as code really allows you to build some transparency, trust, and automation into your software governance process, which is just becoming so critical today because of the ever growing amount of automation that we rely on. So PAC really allows you to govern your highly beneficial automation that you've built. Now, some platforms that help you out with this, Grapheus we talked about, it's highly customizable, but it does require you to do a good bit of scripting. It's open source from Google. Kritis is one that's really focused on Kubernetes-based deployments, highly customized for that, which is also open source. And there's a couple of proprietary ones, like HashiCorp has Sentinel, and there's also Fugue that's out there, which provide PAC platforms, which are proprietary. Now, you want to define your control points based on your particular company's software governance policies, and you might want to use some established patterns when it comes to pipeline orchestration to the PAC platform in order to preserve that integrity and trust. It's quite easy to fall into the trap of just believing what your pipeline orchestrator might say. So to avoid that, take a look at some of those reference architectures and make sure that that's followed. And finally, to kind of adapt this to the mainframe side, many of the control points that you've established as a company will likely apply on the mainframe side as well, but you might want to be open to some customization there. And when it comes to actually automating it and implementing it, Zoe is a key enabler to PAC automation for the mainframe. And from a Broadcom perspective, our software stack on the mainframe is largely Zoe conformant and API and CLI enabled, which should put you in a good place to be able to use them and query them to build up your PAC automation. So this is Sujay Solomon. I hope you've enjoyed the session here on Policy as Code. If you've got any questions for me, I'll be happy to answer them over chat. If you need to contact me offline, feel free to email me directly or reach out to me on LinkedIn or Twitter. So thank you, everybody. Have a nice day.